We're going to solve a literal equation. So we have an equation here, and we're looking to solve for A. So we're solving for A in this equation. So the first thing that I'm going to do is notice that it's A divided by M. So if I want to get rid of that division, I'm going to multiply by M here and M here. The M's cancel. I get A equals M times Z, and that problem is done. I have isolated A. Some teachers may prefer that the A is on the left. I prefer it, but if you wrote the first one, that's fine. So there's my first example of solving a literal equation. Here's my next one. So we had to solve this for x. We have x in each of these terms. So if we look at that as, hey, we're multiplying these two, each of those terms by x, if I factor out an x, which can be confusing to a lot of people, okay? I'll explain it this way. What if we had 2a plus 8? I know that 2 is a factor of each of these terms, so I could essentially, well, I could factor out the 2, which is essentially the opposite process of distribution. Most people are pretty comfortable with distributing that 2 into the parentheses and resulting in the top expression. Okay? It gets a little bit trickier for people when you throw all variables, like in our original equation up here. So if I take out the x out of each of these three things, I'm going to be left with k plus w plus v, right? And the pluses are just going to persevere. They're going to stick right through the factoring. And then now I have a multiplication problem here. I have x, which I'm trying to solve for, times all of this, the sum of k, w, and v, which now if I divide both sides by that same parenthesis, k plus w plus v, the result is that all of that will cancel, and I'll have x alone, and my variables on the other side are u divided by the sum of k, w, and v. Again, you can move the variable to the left if you prefer, but that last step I'm not going to show. That's example 2. That one's probably the harder one that I'm going to do in this process. Let's take a look at number 3 here, and this is also kind of a trickier one. Maybe let's go to 2, and I'll come back to number 3. So again, we're solving for x. We have two variables on the right side that we need to cancel. Both are being subtracted, so I'm going to add c to both sides, and while I'm at it, I'm going to add y to both sides. So I'm going to drop my equation down. The c's cancel, the y's cancel, and on the other side I have g plus y plus c. Okay, and then again, preference, I am going to put the x on the other side this time, and then I'm going to also put my variables in alphabetic order. Alphabetical. That just didn't sound right. So there's my answer for number 2. And then lastly, at least for this video, we're going to look at, user error. We're going to look at number 3. And the main difference here is that the variable that we're trying to solve for is in the denominator. So that's what makes this one a little tricky. First, I'm going to get rid of both the w and the v. All right, so they're both one is being subtracted, so I'm going to add v to both sides. If I subtract w, all of those will cancel from the right, and I'll have u plus v minus w equals k divided by x. Since I'm dividing by x, I'm going to multiply both sides by x, which would look like that. I do want to make a special note here that x does not equal 0. Because if I multiply by 0, I've got a problem there, right? And x is in the denominator. If it's 0, the whole thing's undefined. So now I can cancel the x's, and I get k equals x times u plus v minus w. And again, I'm solving for x. If I were solving for k, I would be done, and we'd be happy. But we have one more step to do. And since there's a multiplication on this side, I want to cancel the multiplication. I'm going to divide by that entire parenthesis, just like in example number 4. Once I do that, all of the parentheses cancels, and I get x equals k over u plus v minus w, and that is my answer. Solving literal equations.